Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.103. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. Ohm's law will also be utilized while solving this problem. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 2.103. Find the value of resistance R in given below figure such that 50 volt source supply 100 watt of power. This is the circuit diagram of given problem. Inside this network we have to find the value of this resistance R while one information is given: power supplied through this 50 volt source is 100 watt. So without wasting time, let's proceed towards the solution. First of all, we will try to find out total supplied current through this voltage source. For that purpose, we will use power equation, that is the product of voltage and current. If we know any two quantities, we can calculate third quantity. In this case, we know the value of voltage across this voltage source and power supplied through it. So we can calculate current through it using this equation. I is equal to 100 watt divided by 50 volt. So the value of I will be 2 ampere and the direction of current I will be in clockwise direction, leaving from positive terminal and entering from negative terminal. Modify the network by indicating current through this branch. Now this same current with same direction will also be flowing from this 5 ohm resistance due to series connection. So we can calculate voltage across this resistance using Ohm's law. Voltage across this 5 ohm resistance will be the product of 2 ampere and 5 ohm. It will become 10 volt. And polarity notation of this voltage will be positive terminal here and negative terminal here. Modify the network by indicating voltage polarity across this 5 ohm resistance with their value. Now on this node, two currents are entering and both are of 2 ampere. So we can calculate current through this branch using Kirchoff's current law. Apply Kirchoff's current law on this node. Entering currents will be taken with positive sign and we are assuming current I is flowing through this branch and it is leaving from this node. So leaving current will be taken with negative sign. Now add 2 ampere and 2 ampere together, it will become 4 ampere and place this minus I on the other hand side of equal to calculate its value. So the value of current I through this branch will be 4 ampere. After getting the value of current through this branch, we can calculate voltage across this 2 ohm resistance, that will be the product of 4 ampere and 2 ohm. So voltage across this resistance will be 8 volt and polarity notation of this voltage will be positive terminal here and negative terminal here because the direction of current is clockwise direction. Modify the network by indicating voltage across this 2 ohm resistance and current through this branch. Now we will apply Kirchoff's voltage law through this outer closed loop to calculate voltage across this resistance R. For that purpose, we will assume the direction of current in clockwise direction. And according to this assumed direction of current, polarity notation across this resistance is marked. Now write KVL equation for this closed loop. Start from here. Current entering terminal is positive, so VR will be taken with positive sign. Next, current entering terminal is negative, so 50 volt will be taken with negative sign. Next, current entering terminal is positive, so 10 volt will be taken with positive sign. And at the end, current entering terminal is positive, so 8 volt will also be taken with positive sign. Now add 8 volt and 10 volt together, their sum will be equal to 18 volt and subtract 18 volt from minus 50 volt, the answer will be minus 32 volt. Place this minus 32 volt on the other hand side of equal to calculate voltage across this resistance R, that will be equal to 32 volt. After getting the value of voltage across this resistance, and we also know the value of current through this resistance, so we can use Ohm's law to calculate resistance value. So the value of resistance will be equal to 32 volt divided by 4 ampere. 32 volt is appearing across this resistance and 4 ampere is current passing through this resistance. So the value of resistance will be 8 ohm. This was exercise problem number 2.103. Thank you. See you again in next video.